Hello, everyone. Welcome to our CCNA weekly meeting. We'll host this meeting every Monday, 9:30 p.m. to 10:30 p.m. over Zoom, and we'll be covering Cisco's CCNA certification materials. Um, Please use this videos as a supplemental to your preparation. What I mean is you're expected to watch some videos, you're expected to learn the topics, um, and then you can come join the meeting um, or watch the video later to refresh your understanding about the subjects. Um, so first of all, let's talk about CCNA certification. So there are multiple certifications in networking and cybersecurity that you can do by various companies. Some companies give you a certification that you can go and use in any company. That's what we call vendorless. But some companies they require or they teach you specific to a technology. For example, let's take CCNA. CCNA, which stands for Cisco Certified Network Associate, teaches you certain skills in network fundamental, access IP connectivity, and all of this stuff focused in Cisco's network devices. Well, what's Cisco? Cisco is a huge company that makes network devices, applications, and certifications and resources for small individuals, um, individual businesses to big enterprise. If you learn networking fundamentals along with CCNA, this should help you crack your first network engineering job or any kind of IT related job in the market. Because having this certification lets the employer know that, oh, you have at least the bare minimum knowledge about how an enterprise system is made or is run. Um, so that's basically what CCNA is, what Cisco is. This I would suggest go on this website and look everything. You can download the CCNA guides, you can download the resources. Um, but for this session, what we'll particularly focus on is this YouTube playlist, which is if I just go to YouTube and I just search CCNA, the first playlist that pops up, it should be from Jeremy's IT Lab. We're gonna be going over this YouTube playlist particularly. So how it works is you watch these videos before the meeting, and then we will refer to these books. The author of the books is the same person as this. So this note will have the link to the books. All you have to do is just sign in with the FUNet ID, and then you will go and access those books. We'll be starting by we will be starting from volume one, Acing the CCN exam by Jerry McDowell. So this book quickly goes over network fundamentals, network devices, cables, TCP/IP networking model, Cisco IOS, CLI, and bunch of networking topics. And all these topics are run concurrently with this playlist. Okay, so we'll be following the YouTube playlist, we'll be following the book, and along with that, in this YouTube playlist, make sure you watch the second video because the second video specifically is about flashcards. So this guy has provided us flashcards in each of the videos. Here I have downloaded the two flashcards for day one and day two. So that's for each YouTube videos he has posted. In the class, we'll also go through flashcards. It's a good thing that you can download it and use it. The software we use is Anki. You can also Anki on a mobile phone is paid version, so you can download other flashcard apps that and then you can import these um, files he has provided for each flashcards. Um, so yeah, that's what the meeting will be about. And today we'll start off the first two videos. So let's just quickly see what the first two videos are. Network devices. And so that's day one and day two. We're going to focus on both in the first lecture. The first lecture is about network devices, and then it's interfaces and cables. So first we'll learn about a bunch of network devices used in enterprise, and then we'll see what do we use to connect those network devices across a building, across a room, what else, right? So we'll go with network devices first. Okay, so this chapter mostly covers a definition of a network, types of network devices, including clients, servers, switches, routers, and firewalls. I'm pretty sure people have heard what a network is already, what a server is, what a switch is, what a router is, what a firewall is. We will see how you actually um, first denote those devices on a diagram and how you connect it. Let me go over this um, picture first of all. So if you see, this building is a Tokyo office. So this office is located in Japan, and this building is located in New York City, right? So this diagram shows how different network devices are connected inside the New York office and inside the Tokyo office. And then how these devices are connected is a whole different story. This cloud here means that, okay, the job of this diagram is to only show how devices are connected inside the offices. And it's we don't know how these are connected here right now. Okay, so this one whole thing is called a LAN. It's called a local area network. And what is a local area network? It's a group of interconnected devices in a limited area, such as an office. Okay, I'm gonna copy this and put it in our notes. Connection between offices is called a wide area network. So this whole connection is called a wide area network. I mean, definitely, right? Because it extends over a large geographical area. So that's why it's called a wide area network. Okay. So what are these devices, right? So if you see this one is a computer, this looks like a, I don't know, server or something. And we don't know what this is. This looks like a wall. So maybe this is a firewall, right? So let's see what each of the devices are. But before that, let's see what a network is. Again, network is just can mean anything. But what a computer network is means it's an interconnection of different nodes on a computer. Okay, there you go. We can define a computer network as a telecommunication network that allows nodes to share resources. What can the resources be? The resources can be a printer. You guys can share a printer that can be a network. You guys can share a monitor that can be a network. You can share fax machine that can be a network. You can share a bunch of stuff between a computer network and it will be a network. So what is that printer called in that network? It's called a node. Computer connected on a network is called a node. A server connected is called a node. So anything that's on a network is called a node. As you see, a node is a device that connects to a network. So anything, including firewall, routers, switches, anything is called a node. So when we talk about nodes, node is any device that connects to a network. Well, what is resources? As like I already said, It's anything that can be accessed or used over the network. What are the types of network, right? So, so what are the types of network devices? So, as we talked about what a node is, it's a device that connects to a network. So, what are those types of network devices that we can use to share resources over a network? So, let's see what a client and a server is. I mean, in a restaurant, go to a restaurant to eat, you are a client, and the server serves you the food. So by basic thing, you should understand that, okay, client is a workstation that wants something from the server, and server gives it to the client. Let's read over here. I can representing a desktop computer and a file server. So possibly this desktop computer is trying to access some files from this server. Can be an FTP server that is hosted over the network, and you can access files from this server. Client is a device that actually accesses services provided by a server, and a server is a device that provides services to the clients, which is pretty self-explanatory as you read it. So it's a client and a server. A server is also used to refer to a kind of device, a very powerful computer designed to be able to provide services to many clients. So if I'm using the server for a file transfer protocol, I won't be using this machine as a regular day-to-day use. I'll have a separate machine, a client machine that I'll use for my day-to-day regular use, and the server machine is only be used to do server-related tasks like updating a server, securing a server, adding functionalities to a server, right? So what are the different examples? It can be a network-enabled TV, can be a client. But if you run on Netflix on that TV, so the Netflix server that provides you with the video and the movies is server, Netflix server. Well, you can go to this chapters and read everything. A quick example, right? A client requests the server saying, send me file X, and the server gives back the file X. That's what a server and a client relationship is, right? Client and server nodes are called endpoints and end hosts. If you're working or if you apply to various internships and jobs, they will have requirements saying, oh, you need to have experience related to endpoints management. So what is endpoint management or endpoint host means? Like every server or workstation on the network. You log into any computer in FU library or in the computer labs, you're working on an endpoint, right? And the second type of network device is called a switch. So now you have to understand a few things. I'm going to go back here, the big picture over here. This is a client, this is a server, this is a server. And the thing that connects all these things is called a switch. Okay? So the things that connects things inside a network is called a switch. Let's go in more deep, right? Devices connected to the switch are able to communicate with each other via the switch. So switch gives a communication um, access to these devices to communicate with each other, right? The role of the switch is to connect devices within a LAN. You have to make sure it's the role of the switch is to connect devices within a LAN. Okay? And a switch will have a lot of ports. Why? Because there can be 21 computers in a building or in a floor. So or in a room. That means I need 21 ports on the back of a switch to connect all those computers. So if you see a network devices with a lot of ports, possibly it can be a switch. Okay, so Switches use various technologies to facilitate communications between the devices connected to them. I mean, yes, you can, like, we'll discuss a bit about on the chapter two. That's an interconnection media, how a switch connection works. But mostly it says in chapter six, so we'll figure that out when chapter six starts. The third type of the network devices is called a router. As you see, I'm connecting all my local machines into a switch so that they can interact. And this switch has a connection going into the router. Okay. So if, if you don't know that all the internet connection that goes in and out of the LAN or an office is generally through the router. So this router is the gateway between the LAN and the internet. Okay. So if you see over here, for example, for endhost to communicate over the internet, we need a device that provides connectivity between the LANs and the internet. And that type of device is called a router. So everyone has routers at home. What's that router doing? It's allowing you to connect devices to the Wi-Fi, and then you can access the internet through that, right? A cloud icon is used in a network diagram to represent parts of a network that are unknown or unimportant to diagram. That means this right now, we don't care about it for this chapter. We may care about in the future. What we care about is this diagram over here. Okay? Routers are not used to connect many end hosts. Why? Because let's say in New York office, let's say there's 3 floors. Max to max, I would need 3 switches connecting to this router. I don't need 21 ports on the router because there won't be 21 switches connecting to that router, right? So that's why router only has um, a few ports connecting to it. Instead, they are placed at the edge of a LAN and used to enable communication between LANs and external networks. So that's the reason why they don't have a lot of ports. So if somebody gives you a photo of a router, let's see. There you go. Right. But just compare the ports. Look how many ports are there in the switch versus a router, right? There are different routers as well, which is called wireless router. So if that's a router, what is a wireless router? So it's a multifunctional device that combines all of different network devices that will have a wireless connectivity and a wired connectivity as well. The fourth type of network devices is called a firewall. Now, firewall can be a physical firewall that means it can be a physical firewall like this, like a box that possibly you will connect incoming connection from the internet to the incoming port and out, and then connect the other end to the router as shown as this. So any traffic passing through the network goes through the firewall. And what does the firewall do? Um, it's used to maintain and monitor the network, mostly monitor the network traffic to protect the network. Um, Basically, what it means is, you don't want unauthorized connection to your network. So you will have a firewall to block unauthorized access, or you want to block people accessing social media while connected to your company's network. So you would want to block connection to that, let's say Facebook's IP address, right? So what it does is it blocks and allows connection in and out of the network. That is what firewall means. Network firewall is a separate hardware appliance that serves a purpose similar to a host-based firewall. What is a host-based firewall? A common example is Microsoft Defender. So host-based firewall is used in an endpoint device like this, like a server, like your machine If you use a Windows server, you use Windows Defender. If you use a Linux server, you'll probably use IP tables to enforce firewall rules and policies. Those are called host-based firewall. But this firewall right here is used as a network firewall to monitor the access of data in and out of the network. And it's generally placed before the router so that you can monitor everything before anything gets into the network. When an attacker is there, the firewall is going to block it. But if it's a valid connection from this computer to that server, it's going to let it go. Firewalls are not a major focus of CCNA. So as I said, it's not a major focus, so we'll focus on what's important. Let's go with the summary. We know what a local area network is. It's limited in a small area. Wide area network extends over a large geographical area. Node, any device that connects to a network is called node. A computer network is a communication network that allows nodes to share resources. And we learned about everything. So before moving to chapter 2, let's go and solve our flashcards about network devices. Dash firewalls are software applications that filter traffic entering and exiting a host machine like a PC. The keyword here is a host machine. So I talked about two firewalls, a host-based firewall and a network firewall. So host-based firewall looks something that's the correct answer for this question. Let's see. A host-based firewall. So for me, it was easy. For you, do it yourself, right? What does this symbol represent? Okay, this doesn't look like, it doesn't have arrow. That means it's not a router, it's not a switch. Okay, it doesn't look like a wall, then it's not a firewall. Well, it can be either a workstation, that is a client, or a server. I know a client has a computer monitor on it, so this is probably a server. There you go, a server. A dash provides connectivity to hosts within a LAN, within the same LAN. Okay, a dash provides connectivity to hosts within the same LAN. Let's go back to our picture first. This is a LAN, right? If I'm talking about a firewall and a router, the firewall monitors the connection or internet passing through the network. A router connects the LAN devices to the outside internet. Well, what does a switch do? Well, switch connects all these local computers between each other and also with the internet. That means switch provides connectivity to hosts within the same LAN. There you go. What is this symbol? It looks like a wall, firewall. A firewall which combines a traditional firewall with more advanced filtering functionality is called a dash firewall. Let's go and see in firewalls. Okay. Well, it's not like said particularly. Um, what's the question? A firewall which combines a traditional firewall with more advanced filtering functionalities with is known as. I'm gonna go with a next generation firewall. There you go, a next generation. So the reason why I could answer this question is because you keep hearing such words, the more and more you learn. So whenever it says it's contrasting between a traditional firewall to something more advanced, it might mean a next generation firewall. What that actually means is this part over here, advanced filtering functionalities. So you can filter your data coming into your network with more selection. And also, also check each packets coming in and out of it. So that's what it's called a next generation firewall. I'm gonna put it over a hard. For me, it was a good, but if you didn't know, never heard about next generation, then yeah, I suggest putting it hard. Okay, a dash is a device that accesses a service made available by a server. Okay, accesses a service made available by a server. So I'm trying to see what is the thing that accesses service between a server. Let's say I'm a client over here. I want this server that has some files stored in it, and I want to ask. So I'm gonna use the file service on our network to request that file. That means I'm a client. I'm a client. What does LAN stands for? Local Area Network. Okay. AN is area network, L is local. Local area. Easy. Okay. Dash is used to send data over the internet. Okay. Look at this. Client, server, switch. Switch connects all the local devices, but switch is not sending this data over the internet. Router connects a switch with the internet. That means router is used to send the data over the internet. Let's see. A router is used to send the data over the internet. Okay. A computer network is a digital telecommunication network which allows Dash to share resources. Okay. A computer network is a digital telecommunication network which allows what to share resources. So what are those tiny things over here? What are these things called that share the resources? Let's go up. Actually, let's go to this over here. Node is any device that connects to a network, and a computer network allows nodes to share resources. You see? So it's node. Okay. Dash and DAS are also known as end hosts and endpoints. Oh, okay. What are the end hosts and endpoints? You was using the computer on the network, a server that's giving the services. So a server and a client, or a client and a server, are called the end hosts. Okay, server slash client. What does this symbol represent? There you go, you see it there. So you're sending data through a switch. This is what a switch symbol is. Arrows going bi-directional. Okay? Easy, right? A dash monitors and controls network traffic based on configured rules. Okay, let's go down. What is the thing that's controlling the network traffic and not allowing an attacker? A firewall, right? Okay. A dash is a device that provides function or services for clients. Okay, it provides a service for client. That means it's a server. What kind of network is a Cisco A? What kind of network device is a Cisco ASA? Well, we didn't talk about Cisco ASA, but let's go and see what Cisco ASA looks like first. So it's a Cisco Adaptive Security Appliance and it's under firewalls. So it's going to be firewall. And the reason why that question was here is because he probably taught you in the first lecture. Okay. A dash has many network interfaces for end hosts to connect. Okay. Tell me which of the device has the most devices connected to it? A switch, right? A switch allows many devices to connect. And all those devices are mostly end hosts. Switch. Routers have dash network interfaces than switch. How many devices a switch is connected to? 4. How many is router? 2. That means a router generally has less network devices than switch. fewer. Okay, what does this symbol represent? So this symbol represents a router. Okay, the faster you memorize it, the better. Can a single device be both a client and a server? Hmm. Yes, it can be. It's not preferred to use your server computer as a client, but yes, it can be. If you know something about ring topology, there is nothing central like a switch connecting them. Each computer, but there's no central computer like a server that everything is connected to, right? So each of these devices have their own client and their own server. Yes, they can. What kind of network device is a Cisco ISR? Okay, let's see. Cisco ISR. Okay, a router, right? A router. Router. So I'm gonna put over notes here. Cisco ASR was a firewall. Cisco ISR. Firewall which combines a traditional firewall with more advanced filtering functionalities is known as, we went over this question already, it's a next generation firewall. Okay. What kind of network device is a Cisco Firepower? Oh, Cisco Firepower. Let's see. Cisco Firepower series is falls under firewall. Okay, let's check. Under firewall. Let's put it over there too. Good way to memorize it is the fire mentioned in it. Okay, we are done with the first deck. I'm gonna try to put all of this. This will be the notes. Predict notes. I'm gonna add one more sub tab and it's going to be questions from the flashcards pasted later in the section there. Okay, let's move to the second chapter. Cables, connectors, and ports. What are cables? The wires. What are the type of wires? Oh, what are the connectors? Oh, what ports are those wires connected to? Right? Okay. So chapter 3, cables, connectors, and ports. We will learn our specifications and standards that allow computers to communicate, the fundamentals of traffic over network, types of wired connections, and cabling standards, the use of unshielded twisted pair and fiber optic connection in the network. Okay, let's quickly see what are the things that we will learn in this, okay? We'll learn about what interfaces and cables are. What is a RJ45 connector, Ethernet, network protocols, bits and bytes, Ethernet standards, UTP cables. UTP means unshielded twisted pair cable. You can see right here. 10 base T, 100 base T, straight through cable. We might not finish this by 10:30. We'll cover this in the next week thing. We'll learn about what a straight through cable is, what a cross through cable is, what is auto MDIX. We'll learn about 1000 base T, a 10 gigabyte base T, and how fiber optic connection works, what's a multi-mode fiber, what's a single mode fiber, different standards, and a bunch of quiz questions. So let's quickly see what we can cover for now, right? So how are data transmitted over wire or internet? It's either with bits and bytes. Um, a file can be X gigabytes in size, but we refer an internet speed in gigabit. Okay, so you have to understand where is a bit is used and a byte is used. A megabit is used to mention the speed of an internet. Okay, normally a megabyte is not used. A byte is not used to tell the speed of an internet. Okay, and there's zeros and ones. Zero means it's off, one means it's on, right? And just manipulating those bytes, you can turn a computer up, turn on a machine, turn off a machine. Zeros and ones can also be fed into a file, right? Oh, exam tip. Understanding the binary number system is very important for the CCNA exam. In future chapters of this volume, we'll cover how to count in binary and how to convert between binary and other number systems like decimal. I mean, if you have taken logic into design, computer architecture, or any introduction to computing or any logic course on your engineering course, you should know how to convert between binary and other number system. Mostly it's the binary, decimal, and hexadecimals. So this is what it's showing how an electric signals looks like. So there's a bit value, and so this electric signal is being transmitted from the router switch. This electric signal is trying to transmit this bit value to the switch. And how it works is, okay, first the voltage will be zero, off. It will be off, on, and off, depending upon the bit values, right? And let's count how many bits are there. 1, 2, 3, 4, 5, 6, 7, 8. There were 10, so there were 8 bits, and 8 bits is 1 byte. Okay. We measure the speeds of network connection by how many bits can be transmitted per second over the connection. However, due to the incredible speeds of the computer network, we express these rates using larger units like kilobits, megabits, and gigabits. As I said, did you see anything that says bytes? No. So network speeds are then said as X bits per second. Kilobits per second, megabits per second, 10 gigabits per second, right? So it's always GBps. You see that small b stands for bits. If it's a big B, it's a byte. Okay, let's quickly go over what a twisted pair cable looks like. So what a twisted pair cable looks like is this, right? There are 4 sets of twisted pair cable. If I go and look at this connector, it will have 4 connection wires. We will learn later under crossover and under straight through cables to see how many of those pins actually work in each cable, and depending on each devices how many of the pins are being used. So switch to client connection will use two number of pins. Um, I might be wrong, but let's go and see. So between a PC and a switch, you will have a transmit and a receive thing. So this first two pins is only used to receive it, and the rest four pins is used to send the data from switch to PC. Between a router and router, there you go, it clashes because this router is trying to send data and this is also trying to send data. So you need to switch these receiving pins, and that's where this crossover cables come. And nowadays, modern connection already has MDIX. What it does is auto medium dependent interface crossover. So this automatically does those crossovers you require. So we will cover those topics in the second meeting. Before I go, I want to go towards the end of the first day video. Go with the quiz again. Your company wants to purchase some network hardware to which they can plug 30 PCs in your department. Which network device is appropriate? Well, I'm trying to connect 30 PCs. First of all, PCs are endpoint or end user devices, right? They are clients. I connect clients, different clients using a switch. So I should have already gotten this answer just by reading this part, right? One more thing to pay attention to, I'm connecting many endpoints. A router doesn't have that much port. That means it should be connected with a switch. So is it a router, a firewall, a switch, or a server? Let's see. It's a switch. A firewall is not used to connect PCs directly. Well, you can, there are ports you can use to connect, but to connect 30 PCs, a router doesn't have that much port. So you will connect it using a switch. And this is what a Catalyst 9200 switch looks like. This is what an enterprise switch looks like. Look how many ports are there, right? 6, 12, 24, 48, 12, 24, 36, 48 ports, right? You can connect 48 devices onto that router there. Let's see at the second question. You receive a video file from your friend's Apple iPhone using AirDrop. What was this iPhone functioning as in that transaction? Okay, I'm talking about my friend's iPhone. I'm receiving a file from my friend's iPhone. So what is the device that sends things over the network? So that file being sent is a resource. What is the device that she allows this client to access? With the third question, what is your computer or smartphone functioning as you watch this video? Okay, I'm watching this video from a YouTube channel, youtube.com. This video is coming from a YouTube server located somewhere, posted somewhere on a content delivery network. This video is coming from there. I'm requesting to watch this video. If I'm requesting to watch this video, I'm a client. Client. This end host here is a tricky one. You are not the end host. You are, sorry, my bad here. You are the end host, but my computer is acting specifically as a client. Both server and clients are called an end host. So be careful on that part. Your company wants to purchase some network hardware to connect its separate networks together. What kind of network device is appropriate? Well, 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 well. There are separate networks together. Okay, let's go back to this. This is a network. This is a network. What am I using to connect this network to this network? The routers, right? Routers. router's there, right? Let's see. Is it a firewall? No, firewall only filters. Host, hosts are the endpoints, right? LAN, I'm trying to connect different LANs together, so it's not going to be the right answer. Router, yes, route, right? Okay. Your company wants to upgrade its old network firewall that has been in use for several years that to one that provides more advanced function. What kind of firewall should they purchase? We already went over it on our flashcards. Comparing an old traditional firewall to a newer one. And that newer firewall is called next generation firewall. It's called a next generation firewall. Let's go over this. Host-based firewall is your Windows Defender, IP tables. There's nothing that's called a next level firewall. And our correct answer is a next generation firewall. And what is a top layer firewall? Let's see what description it has for a top layer. Top layer firewall is not actually a type of firewall as well. Okay, so this was the topic that we learned in the first meeting in CCNA. You'll have access to these notes. You can access these notes at questions sometimes. Of course, the end of this week, if I have time, the next meeting will go over cables, connectors, and AP ports. So let's see, meeting one, let's update this. This meeting covers lectures one from the playlist. All right, thank you for joining. This video will be uploaded on YouTube, so you can watch it anytime.